Okay, you guys, let's look at another rate problem. So here we have experimental data from 3 experiments. And our question says, what is the order of the reaction with respect to the ClO2? So if I want to know how the ClO2 affects, I'm going to choose my 2 experiments where the OH stays the same, but my ClO2 changes. I always want a whole number. It's easier to work with. So I'm going to start with my lower one. And when I go from 0.2 in experiment 2 to 0.06, I am increasing it by multiplying by 3. So this is 3 times. When I look at my rate, it's not obvious just by looking at it, so I need to do my math. So I'm going to take 0.0248 divided by 0.00276, and I end up realizing that it's times 9. So when I tripled my concentration, my rate was times 9. So 3 to the second is 9. So that tells me that this is a second order with respect to the ClO2. Okay, next we want to figure out what's the order of the reaction with respect to the OH. So again, I'm going to choose 2 where the ClO2 stays the same and only my OH changes. I'm going to look from the small to the big. So from 0.03 to 0.09, that's times 3. And then my rate from 0.00276 to 0.00828, that's also times 3. So my concentration is times 3, my rate is times 3. 3 to the first equals 3. So this is a first order reaction. So that means that overall, the order of the reaction, if it's second order in ClO2 and first order in OH, it's third order overall. So let's put it all together then. Our last idea there, what is the rate law for this reaction? So rate is equal to the rate constant, that's our lowercase k, times the concentration of ClO2 squared, because it's second order, and then times the concentration of OH to the 1, which we don't write because it's first order. So now we're going to use this rate law to answer the next questions. So first reminder, this is our rate law. We want to know what is the value of the rate constant for this reaction. So remember, the rate constant should be the same at this temperature. So I can use experiment 1, 2, or 3 to plug data in. So I'm going to rearrange my equation to solve for K, my rate constant. So to do that, I'm going to take rate divided by the concentration of ClO2 squared and OH minus. And then I'm just going to plug in my values. I'm going to use my values from experiment 1. Sorry, you guys, that got messed up a little bit. So it's 0.0248 divided by these concentrations. And then this is my value here, 229.6 molar to the -2, S to the -1. And remember, we're using this because it's third order overall. So it's always seconds to the -1. And then it's the overall order -1. So 3 minus 1 is 2. Okay, and then last up here, if there's an initial concentration of ClO2 equals 0.04 molar and the OH is 0.03 molar, what's the rate of the reaction? We're just plugging our values into our rate law at this point. So we're going back to this rate law. We now have a K value for it. And so we want to just plug those values in. So here's our K value, concentration of our ClO2 squared, and then concentration of our 0.030 molar solution. And our rate is 0.0110 molar per second. Now we want to make sure that makes sense. So the 0.04 would be in between here, and then 0.03 would be the same as this. And so we can see that if we were to double here, this is about a quadruple for our reaction. So that makes sense.